Also, with this being recorded, everyone can look at it later if they need to as well. So let me get this to zoom a little bit. Now, there was a homework problem yesterday that was moving you toward the remainder theorem. Let me briefly bring that to your attention. And it even says, Introduction to the Remainder Theorem. You were expected to plug in these numbers. Let me get this drawing. You were expected to plug 3 into all of these x's, -3 into all of its x's, and so on. So does anyone want to tell me what they got for 5, 6, 7, and 8? Yeah. Okay, that's fine. It's okay. We'll be getting there. So what this is asking you to do is to plug 3 in. So that means that I have 2 times 3 cubed minus 3 times plug in x equals 3 again, minus 11 times plug in x equals 3 again, plus 6, and then do all that arithmetic. So let's see, you've got 2 times 27 minus 27 minus 33 plus 6. And that should end up giving you, let's see, a 27. Does anyone have it? So you're going to get 27 minus 33 plus 6. Okay, that's okay. 27, 6. Oh, wait a minute. That's 0. Oh, my goodness. Now, if I go back over to problem number 1 here, let's go through problem number 1 together from yesterday's homework. If I'm dividing by x minus 3, then I write the x minus 3 over there. And the highest degree term of my polynomial that is being divided goes in the upper left corner. Then I'm trying to figure out what do I multiply this x by to get the 2x cubed, and everyone says you get 2x squared. Yay! Then we can get this box through multiplication of -3 and 2x squared, giving me a -6x squared. The next step is I have to figure out what I need to add to 6x squared to get -3x squared. And whatever that is, that needs to be in the box diagonal to what I'm looking at. Because every batch of diagonals is like terms if it is lined up 1 degree down each time. So what do I add to -6x squared? And I get -3x squared as a result. And you say positive 3x squared? So that when I add them, because that one's a negative. Did I? That's my bad. But I guess that's old lingo too. So I read that wrong. Now, hopefully you're all following along okay. The next thing I'm going to do is figure out what do I multiply x by to get 3x squared, and that would be 3x. And now I can multiply the 3x and the negative 3 to get this box. Now, I need to figure out what I need to add to negative 9x to what I need to add to negative 9x to get negative 11x. I'll be grading your tests this weekend. So this ends up being negative 3x. Then the next thing I do is ask myself, what do I multiply x by to get negative 3x? And that would be negative 3. And notice that I just put a constant down. As soon as I hit the constant, anything that's excess is going to wind up as a remainder. So now I need to figure out just what happens. Negative 3 times negative 3 gives me positive 9. Did I make any mistakes on the way through there?
Yeah, I think it's negative 2x, not negative 3x. Negative 9 plus negative 3 is negative.
Yay! Thank you. Yay! It's my addition abilities. Oh my goodness. So, negative 9 plus negative 2 makes negative 11 for the x. And then x times negative 2 will give me the negative 2x. And now when I multiply these two, I get positive 6. Now, the reason I was asking, did I mess something up, was because I knew that this polynomial is the same one that I just had with number 5. In problem number 5, I plugged positive 3 into all the x's and I got 0. What we're going to recognize or discover is the pattern that if I divide, I'll do this. If I divide this polynomial by x minus the number I plug in, the result is exactly the same as the remainder. That's what this is trying to prompt you toward from last night's homework. I don't know if you figured out what that pattern was, but it makes it hard if you had any mistakes also. So with this one, because, I'll use that color, because this 6 doesn't need to add to anything to get that 6, I was able to contain the whole polynomial without any remainder. Now, that means that the solution to that division, so 2x cubed minus 3x squared minus 11x plus 6 divided by x minus 3 is equal to a full polynomial quotient with no remainder of 2x squared plus 3x minus 2. And so that's what you needed to do with number 1. And there are 4 more, or sorry, there are 4 altogether. There are 3 more of these and 3 more where you plug the number into the x's. And if mistakes weren't made, then what you should notice is that the remainders from questions 1 through 4 are the same as the values we got by plugging those numbers into the function. And those numbers happen to be the 0 of that factor. I know they are very time consuming. So with that said, what do you think should be said here? if f of a equals k, then what is the remainder when I divide f of x by x minus that same a? And your answer is k. Now, let's go over to today's classwork and look at what exactly is the remainder theorem and the factor theorem. Once we get those, then we're just going to do the work instead of theorizing about the work. But you are expected to be familiar with these theorems. So the remainder theorem, when a polynomial is divided by x minus c, the remainder of the division is the polynomial value at c. So you end up getting the polynomial is equal to what you divided by times the quotient plus the remainder, but the remainder is the p of c, is all it's really saying. Now, the factor theorem is very important. The factor theorem says if p of c is equal to 0, then x minus that number c is a factor of the polynomial. And that c is a root of the polynomial. So what I see some of you are writing this down. You can finish writing it down. I've got the answers online. In the meantime, let's dig into what you're expected to do. This is theory. Let's do what needs to be done. Whoops, those are the answers. Okay. You have a degree 3 polynomial. When you have a degree 3 polynomial, you're not going to be able to just use a quadratic formula if you're desperate to find roots. And this actually was a big deal for a long time. People were trying to find a nice third degree polynomial quadratic formula and couldn't find anything that was reasonable to use. And so we're kind of stuck in this particular area. I will only give you these problems where I tell you one of the roots. I'm not going to make you go through the guessing game. So if you know one of the roots, then the first thing you're going to do is say, that means I know one of the factors. One factor of this polynomial is x minus -1. If I divide my third degree polynomial by that 1 degree polynomial, I will get a degree 2 quotient. And that I will be able to apply the quadratic formula to if I have to. If all else fails, the quadratic formula can be used. So let's do that division. Make some boxes. We're dividing by x plus 1. The first thing I'm going to do is put my leading term in the upper left corner. And then I start my division process. What multiplies to x to give me 2x cubed? And you should see 2. Excellent, good. And now that I have that, I can find this box by multiplying 1 and 2x squared. My next step now is to figure out what I need to add to 2x squared and put it in this box. Ah, yes, that will add to make that positive 3x squared, and that would be x squared. Then I have to figure out x times what is x squared? Positive x. And now I can multiply that x times this one. And now I've reached the point of I need to figure out what to add to x and put it here. That will give me negative 9x. And maybe I should turn to you guys so I don't make an arithmetic mistake. What do I get? X plus what will give me negative 9x? Good. Excellent. Negative 10x. And now, x times what gives me negative 10x? Negative 10. And then negative 10 times 1 is negative 10. And I had better have this be the constant of that polynomial. If it turns out that it is not the constant of that polynomial, one of two things happened. Either you made a mistake during your division, or I made a mistake in giving you the problem. One or the other. If something is a root, and you divide by x minus that root, you will get a zero remainder every single time. Now, this problem asked you to find the other two roots. We're going to use the quotient result. So basically that p of x that we began with is equal to x plus 1 times 2x squared plus x minus 10. Now, either we can factor this or we're just going to head over to quadratic formula. Do you guys want to try it or just head into quadratic formula? Okay, let's see if we can find something that'll factor nicely. If you remember correctly, this top piece is a times c, so 2 times negative 10. And then the middle number is positive 1. Are there two numbers that will multiply to make negative 20 and add to make positive 1? And I'm thinking you probably see it, huh? Positive 5 times negative 4 will make negative 20, and when I add them, I will get 1. So this is telling me about how I can start factoring the quotient that I got. As I look at what goes inside the box, where did I get? The negative 20 comes from a times c. So let me show you. If you have ax squared plus bx plus c, and you're trying to factor that, the a times the c goes on top and the b goes on the bottom. And then you're looking for two numbers that multiply to make the top and add to make the bottom. And now I'm trying to factor this quadratic now that I have found a pair of numbers that's going to make this work out. And I'm going to put my leading term in the upper left corner. My constant term will go in the lower right corner. And then I'm going to choose 5x and negative 4x are going to go in these other two boxes, and it doesn't matter what order I do it in. And now I have a little bit of a guessing game. I'm trying to figure out any one of these 4 spots. And anything that goes in a spot has to be able to divide everyone in either its column or its row. So let's start with this column. What will divide both things in this first column? Mm-hmm. And in fact, x is the only thing that's going to divide both of them, so we just lucked out. Now, x times what will give me 2x squared? And I'm assuming you saw the 2x. X times what gives me 5x? 5. And now 2x times what is negative 4x? Mm-hmm. And I hope this worked out. 5 times negative 2. It is negative 10. That is the factored form. Now, you don't have to write as much as I'm writing at this exact moment. I want to point out to you what we just did. We factored a third-degree polynomial into 3 linear factors. We were given something to get the first one going, and now we know that the other 2 are 2x plus 5 and x minus 2. And now the roots are anything that makes any of those factors equal to 0. We already know about the negative 1, but now we have additionally, what will make 2x plus 5 equal 0? And you can write it either as a fraction or decimal. So negative 5 halves is one of my other 2. And the other one is? What makes the last factor equal 0? 2. That is how much work goes into factoring when you go higher than degree 2. And also recognize that you're actually this is being halfway decent because it's giving you one of the roots to start with. I'm going to do one of those. Back in my day, we did not have the technology available to just solve these equations for us. So we had to start with guess a number that works and makes it equal 0. And we would sit there and plug in numbers into all the x's. Did I get 0? No. Try another number. If you can imagine how irritating that is. Then I remember spending probably close to a chapter just learning about how to figure out what your zeros might be. And just, oh my goodness, it was ridiculous and crazy. But you guys don't really have to do that anymore. Guess and check isn't that useful as far as what we spend our time in math class on. And if technology can get us through a bit when it's that bad, I think it's preferable. But I will always give you a number to start with, and you get the joy of going through all this work. But know that it used to be worse. Okay, maybe funny, maybe not funny, I don't know. All right, let's do another one. One of the roots is x equals -2. What does that make as one of the factors of the polynomial? What is one of the factors of the polynomial if we know that a root is x equals -2? And I'm looking at chat. This is your very important first step with these problems. Right. X minus that root. X minus -2 is x plus 2. So when I divide the third degree polynomial by this linear, I will get a quotient that will be a quadratic. And if I'm desperate, I can put that, sorry, wrong phrase. If I'm desperate, I can quadratic formula it and find the other two roots through that. So long division, or actually it's not really, it's box division. Box division, here we go. And everybody cheers for joy. Maybe. I'm dividing by x plus 2. And what's the first thing that I'm going to write down inside my boxes? What is the first thing that I'm going to be able to write down? That leading term. And that leading term is 5x cubed. Now, everyone think to yourself and see if you can stay ahead of me. What is your next move? I'm hoping that you thought, what do I multiply x by to get 5x cubed, and I write it up here. Yes, very good. And now think, what is my next move? And good. Multiply the 2 and the 5x squared. And now what is my next move? And in case you don't see it, what I want to do is point out that I put the leading term here, and that's taken care of. The next thing that I need to be inside the box is positive 5x squared. So what do I need to add to 10x squared to get positive 5x squared? And that is correct. Negative 5x squared is what I need. And now what is the next thing to do? X times negative 5x will give me this negative 5x squared. And next, multiply those two and I get negative 10x. And next, good. I need to figure out what to add to negative 10x so that the sum is negative 7x. Very good. You guys are doing good. And I keep going. X times what is 3x? And 3 times 2 is 6. And hopefully, very, very hopefully, that takes care of the whole polynomial, and it does. I have no remainder, so this is what I intended to do. Now what I have is I found my quotient, and if it's okay with you, I'm just going to erase q of x right now and put what I found it to be, 5x squared minus 5x plus 3. Now, that quadratic, either I'm going to factor it or I'm going to throw it in the quadratic formula. It's okay. So, do you want me to save you pain and tell you that you're going to need quadratic formula? It is not factorable. Or you can try, but I really want to save you the pain. And I know because of these are the problems I prepped for today. Yeah. And let's all remember what the quadratic formula is. And I want to point something out to you inside of it. So, did you guys learn it by singing the yeah. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Oh, Gilligan's Island. Oh, that's better. Sit right back and you hear a tale of a quadratic formula. I don't know. I grew up on Gilligan's Island. Has very fond memories. My brother liked to play the guessing game of how quickly can you determine which episode it is of Gilligan's Island, and he would get it within like 2 seconds, and I hated him for it. I didn't hate him for it, but you know what I mean, if you have siblings, probably. Moving on. So let me point something out to you that can be a time saver in the future. Are you listening carefully? Under the square root, you have b squared minus 4ac. So hopefully all of you can see, I'm going to make sure you're clear on this. I'm going to write down the quadratic 5x squared minus 5x plus 3 and make sure that you see that this 5 is a, this negative 5 is b, and this positive 3 is c. If you want to know if something is factorable or not, find b squared minus 4ac. If b squared minus 4ac is a positive perfect square, then you can factor it. Otherwise, don't even bother. It's a waste of your time. So the b squared is going to give me 25. So I'm just going to write that piece down. B squared minus 4ac is positive 25 minus 4 times a is 5, c is 3, and that gives me 25 minus, can I do arithmetic? 20 times 3 is 60. It's a negative number. If b squared minus 4ac is a negative number, you really can't factor this. That means I is going to come out and we're going to deal with the imaginary number. So this is part of the quadratic formula, so let's just keep going. What is 25 minus 60? Oops, forgot my negative. And now let's write the rest of that. So going back to the x equals, negative b is going to be a positive 5 plus or minus the square root of, we just went through enough work to just throw that in there, divided by 2 times a. 2 times 5 is 10. The first thing you're going to do is take the negative under the square root and bring it out of the square root as a just plain I. That means you have x equals 5 plus or minus I times the square root of 35 over 10. Now, you might be able to write the answer in a more simplified way. Sometimes this just doesn't get any better. One question is, this square root, does that square root simplify? Any perfect squares to pull out? I can divide 35 by 5. 5 times what is 35? Mm-hmm. 5 times 7. So yeah, there are, nope, nothing coming out. That means the best you're going to do is either call it a day and say those are my other two roots, which I am perfectly happy with you doing. But I also know that some people are going to simplify a little bit. If you do, make sure you understand that you have to distribute the division of the 10. So 5 divided by 10 simplifies to 1/2, plus or minus I, and then you still have to have the divided by 10 with the I times root 35. So I don't think that looks necessarily any better. But I'm not going to get on you about simplifying this too much, just for you to get to the point where you have a correct answer from the quadratic formula. Whew, was that fun? I know. Now, next, we're gonna kind of cool down, go with something that's pretty quick. So I'm just going to turn to the answers on this one to have you type them in. Or not type, right? Whatever. Maybe it's type. You are expected to know these 4 vocabulary words, but they're almost self-explanatory. When you talk about increasing and decreasing, know that that is always a view from left to right, because we consider when we are horizontally moving to the right as positive. There are other societies that have it the other way around. Every society, I guess, had to decide what did they think was forward horizontally, and some people chose right, some people chose left. So if you are looking left to right, that means when the graph is heading upward, you are increasing. When the graph is heading downward as you look left to right, you are decreasing. And then over here, I go back to increasing because I'm heading up as I go from left to right. Did those 2 words seem pretty self-explanatory? Increasing, go up, decreasing, go down. Good. Now, relative maximum, relative minimum are also pretty self-explanatory. Those are points. They are points on the graph where the function changes from either increasing to decreasing or decreasing to increasing. They are like little momentary high or low points, because you could say relative to the graph around it, it's the highest point, and that makes it a relative maximum. Over here, relative to the graph nearby, that is the lowest point, so it's a relative minimum. And, oh, yes, also, just to make sure to clarify with you, you're going to be asked in your homework to take a graph that is already drawn out for you and to state the x intervals where it is increasing and decreasing. So let me point this out to you and make sure to clarify. I'm trying to draw a straight line anyway. Okay, whatever the x coordinate is of this point, I'm going to say that this point is a comma some y value f of a. And I'm going to say that the other point is b comma some y value. That means that on the x-axis, this is x equals a, and this is x equals b. This graph is increasing on the x interval of negative infinity to a. It is also increasing from b to positive infinity. This function is decreasing on the x interval from a to b. And when you're asked for a relative maximum point, you're going to put the ordered pair of that point, and it'll be a specific point on a graph that you can read. And then a relative minimum, you'll just put the x comma y coordinate of whatever point that happens to be, and it'll be very clear. Now, one last little thing, and I want to make sure to give you time. Okay, least degree of a polynomial graph. And unfortunately, I'm going to have to kind of say this a little bit quickly, but nah. Now, first of all, you know that if it does disco, it's an odd degree polynomial. You know that if it's a roller coaster ride, or I don't know why you'd put both hands down. Oh, when you start a car race, I think. Anyway, that you have an even degree. But the question is, how high of a degree could it be? And technically, what's going on here is a point of inflection, but I thought I'd give it more of a descriptive word, a wiggle. If you notice a wiggle in the graph, I took some screenshots of this idea of pretend that you are grabbing about there and there, and you are trying to pull the graph into a relative minimum, relative maximum pair. You're trying to pull it into that. Sometimes maybe you aren't successful in creating a little relative minimum, relative maximum. So what you need to be aware of is, have you noticed that when you have a relative, what am I trying to say? I'm trying to talk too quickly and it's not going to work too well. Okay, when you have a second degree polynomial, you have either a relative maximum or a relative minimum, right? A third degree polynomial might have a relative maximum and a relative minimum. A fourth degree polynomial might have a relative minimum, maximum, and then another minimum. The pattern that hopefully you're seeing is you can have at the most how many relative minimum maximums based on the degree. So this is degree 2. This is degree 3. This is degree 4. The most you can have for minimums and maximums is 1 less than the degree that you are. But these wiggles are an attempt to make a maximum minimum pairing. So you can either follow a formula or you can think about it and count in a variety of ways. But basically, if you take the number of relative minimum maximums and add 1, and if you have some of those little wiggly things, for each wiggle, you need to add 2 because they're basically, that wiggle is basically one relative minimum and maximum together being a duo. That will tell you the least degree of the polynomial that you see. And I'm going to move this now to give you some examples, and you can look at this later. Yes.
Do we have a quiz for that?
Yes, that's why I'm trying to keep moving.
We have 1 minute.
No, we don't. We have 6.
Do we have 5 minutes left?
Yeah, on Fridays we get out 5 minutes later.
Oh.
Yeah.
No worries.
Yeah. So we're running out of time because I do need to get you into the quiz. So you need to look at number 3. You need to see that you have, this is kind of a wiggle and a relative minimum. What is the minimum degree? Also notice it's an even. Notice it's even and let that help you out. This is a minimum degree of 4. And the leading coefficient, you can just look at the right end and determine positive, negative. For this next one, you have 1 maximum, 1 minimum, 1 maximum, and I don't see any wiggly things. So that one also has a minimum degree of 4. And the right end goes down, so a negative leading coefficient. This next one has a relative maximum, let me highlight, maximum, minimum, a wiggle, maximum, minimum. So I've got 4 maximum minimums. The wiggle is trying to make another pair of maximum minimums, and then I add 1. Notice also that it's an odd degree because it's doing the disco thing, and the minimum degree is 7. And because it is going up on the right end, it is a positive leading coefficient. I'm going to quickly go through the next 3 and then open your quiz. A wiggle, a relative maximum. Minimum degree is 4. Right end goes down. Right end goes down, and I have a minimum, maximum, minimum, maximum. 4 of them. I don't see any wiggly things, so it looks like degree 5 is its minimum degree. And again, it's the odd disco thing. And then the last one, your leading coefficient is positive because the right end goes up. And then as you look at it, you want to see 1 minimum, 1 maximum, another minimum, and a wiggly. So that's 1, 2, 3. This counts as 2. And then always add 1, and then make sure this is showing the same direction. It should be an even number. You got 6. That is an even number, and that's its minimum degree. Okay, I'm going to open the quiz up for you so that you can get going sooner rather than later. So